Have you ever seen a photo of a car crash and thought, man, that car is just completely mangled. It must have been so unsafe. Well, what if I told you that the very reason it looks so destroyed is exactly what kept the people inside alive? Yeah, I know, it sounds totally backward. But today, we're going to dive into the wild physics that show how making cars weaker in some places is, believe it or not, the secret to saving lives. So, to kick things off, I want you to step into the role of a vehicle safety engineer. You've got a massive decision on your hands, and it's literally a matter of life and death. Your job is to pick the safest design for a brand new car. All right, here are your choices. The dark blue stuff you see is a super strong, incompressible metal. Think of it like a solid steel beam. The yellow stuff is a special alloy designed to compress, bend, and deform. So what's it going to be? The design with a rigid frame? The one that's totally soft? Or some kind of mix? Go ahead, pick one, and keep it in mind, we're about to figure this out together. To find the right answer here, we can't just rely on gut feelings. Nope. We need to become physics detectives and uncover the clues that explain what actually happens in a crash. So our very first clue is a little concept called momentum. You've definitely heard the word before, but what does it actually, mean in physics terms? The easiest way to think about it is inertia and motion. A bowling ball hurtling down the lane has a ton of momentum. It really, really wants to keep going. A little ping pong ball just floating along? Not so much. At its core, it's about how much stuff is moving and how fast that stuff is going. And the formula couldn't be simpler. P equals m times v. Momentum is just the mass of an object multiplied by its velocity. This means a huge, slow-moving truck can actually have the exact same momentum as a tiny, fast-moving sports car. Okay, time for our second clue, and I gotta tell you, this one is the master key to this whole puzzle. It's a concept called impulse, and it is what really defines the physics of an impact. So, what is impulse? It's simply the change in an object's momentum. When that bowling ball finally smashes into the pins, an impulse is what brings it to a halt. It's the oomph of the impact, and it's created by a force happening over a certain amount of time. The formula is impulse equals force multiplied by time. And this right here is where things get super interesting for an engineer, because those two variables, force and time, those are the levers we can actually pull to control the outcome of a collision. And all this leads us to the big central rule that ties everything we've talked about together. This is known as the impulse momentum theorem, and it's the secret weapon for our entire investigation. So it all boils down to this one beautiful relationship. Force times time equals the change in momentum. This single equation right here is what we need to solve the entire mystery of car safety. Now, before we get back to those cars, let's put this principle to the test with a much simpler, classic thought experiment. Think of it as a little mini mystery. Okay, picture this. You drop an egg. Now, here's the key part. Whether that egg hits a fluffy pillow or a hard concrete sidewalk, its momentum changes by the exact same amount. It goes from moving to a dead stop. So the impulse is identical in both cases. The big question is, why does one egg survive the fall while the other one, becomes breakfast? Let's look at the numbers, because this is where it all clicks. The soft pillow stretches out the collision to 0.2 seconds. That results in a really gentle force of only 15 newtons. The egg is perfectly fine. But the concrete, it stops the egg in just 0.05 seconds, a fraction of the time. Now, since the change in momentum has to be the same, the only way for the stop to happen that fast is for the force to absolutely skyrocket, all the way to 60 newtons. And splat. That's the end of our pour. And that right there perfectly illustrates the secret. It's a trade-off. For the exact same impulse, if you can increase the amount of time the collision takes, you drastically decrease the force of the impact. It's a simple inverse relationship, and it is the absolute key to survival. Okay, now that we're armed with this powerful understanding of impulse, let's go back to our engineering challenge and finally solve this thing. So, after all that, the safest design is, drumroll please, vehicle number 2, the one with the compressible front and back and the rigid passenger cabin. If that was your choice from the start, nice work, you nailed it. So why does this design work so well? Well, those compressible yellow sections are what engineers call crumple zones. And just like the pillow did for the egg, their one and only job is to deform, bend, and collapse during a crash. This act of crumpling extends the duration of the collision. And as we just learned, more time means way, way less force reaches you, the passenger. All the while, that rigid blue cabin holds its shape, acting like a protective safety shield. Now, let's compare that to the so-called tank design. That fully rigid car might look incredible after a crash, maybe not even a dent on it. But that's a terrible sign. Because it doesn't crumple, the impact time is almost instant. And that means a massive, devastating force gets transferred directly to the people inside. The car with crumple zones, on the other hand, looks like a total wreck because it sacrificed itself. By extending the impact time, it kept the force on the passengers low enough to be survivable. So here's really the bottom line for any safety engineer. In a crash, the change in momentum, that impulse, is pretty much set in stone. The car is going from a certain speed to zero. You can't change that fundamental fact. But what you can control are the ingredients of impulse, force and time. By designing a car to crumple, you are consciously making a choice. You are maximizing the time to minimize the force. And this brings us to a very real modern-day dilemma. This amazing safety feature means that even in a pretty minor accident, a car can be declared totaled because its crumple zones did their job perfectly. This, of course, can lead to higher insurance costs and cars being written off way more easily. So I'll leave you with this final question. Knowing the physics now, do you think this financial cost is a fair price to pay for survival?